Welcome to Algiama's Prep Academy. The lesson for today is finding local maximums and local minimums using the first derivative test. A local minimum is when f prime of x is less than 0 to f prime of x is equal to 0 to f prime of x is greater than 0. A local maximum is when f prime of x is greater than 0 to f prime of x is equal to 0 to f prime of x is less than 0. Local minimums and maximums can also look like this. This is where, for a local minimum, f prime of x is less than 0 to f prime of x is equal to undefined to f prime of x is greater than 0. And for a local maximum, f prime of x is greater than 0 to f prime of x is equal to undefined to f prime of x is less than 0. For local maxes and mins that have an undefined like this, to determine whether they are continuous, we have to use the continuity test. The continuity test can be broken down into 3 simple steps. First is to see if the function has a point at the undefined. Secondly is to see if the limit of the function at this point exists by getting the left and the right side and to check if they are equal. And lastly is to see if the point and the limit are equal. If all of this is true, then the function is continuous.
Problem 1. Find the local minimum and local maximum of the function f of x equals 2x squared divided by 3x plus 1. We have to find the first derivative of f of x using the quotient rule. The derivative of the numerator times the denominator minus the numerator times the derivative of the denominator divided by the denominator squared. The derivative equals 6x squared plus 4x divided by 3x plus 1 the whole squared. The second step is to find the critical points of f, where the derivative is 0 and where the derivative is undefined. The derivative equals 0 when x equals 0 or when x equals negative 2/3. The derivative is undefined when the denominator is 0, when 3x plus 1 the whole squared equals 0. So the derivative is undefined at x equals negative 1/3. The third step is to make the derivative number line to find the possible local minima and the local maxima. The function has zeros at x equals negative 2/3 and x equals 0. The function is undefined at x equals negative 1/3. We plug in values to get the signs for the derivative number line. Since f prime of negative 1 is equal to a half, the derivative is positive over the interval negative infinity to negative 2/3. F prime of negative 1/2 is negative 2. So the derivative is negative over the interval negative 2/3 to negative 1/3. At x equals negative 1/6, the derivative is equal to negative 2. So the derivative is negative over the interval negative 1/3 to 0. F prime of 1 is equal to 5/8, so the derivative is positive over the interval 0 to positive infinity. The derivative is undefined at x equals negative 1/3. Before drawing the graph of f, we need to check the undefined value. Since f of negative 1/3 is equal to a number divided by 0, f has a vertical asymptote at x equals negative 1/3. This means that there cannot be a local minimum or a local maximum at x equals negative 1/3. The next step is to draw the graph of f. The vertical asymptote is located at x equals negative 1/3. Since the derivative is positive over the interval negative infinity to negative 2/3, the graph of f increases. Since the derivative is negative over the interval negative 2/3 to 0, f decreases while approaching the asymptote on both sides. Since the derivative is positive from 0 to a positive infinity, f increases. Now we find the relative extrema. The function has a local maximum at x equals negative 2/3, since the derivative changes from greater than 0 to equal to 0 to less than 0. F of negative 2/3 is equal to negative 8/9, so the local maximum of f is f of negative 2/3 equals negative 8/9. F has a local minimum at x equals 0, since the derivative changes from less than 0 to equal to 0 to greater than 0. F of 0 is equal to 0, so the local minimum of f is f of 0 equals 0.
Problem number 2. Find the x-coordinate of the local extrema of f of x equal sine x plus cosine square x on interval of 0 to 2 pi.
First, we take the derivative of the function, which comes out to be f prime of x equal cosine of x minus 2 cosine x times sine x. Now find the critical numbers of the function where f prime of x equals 0 and undefined. So we set the derivative equals 0 and x comes out to be pi over 2 and 3 pi over 2 and also pi over 6 and 5 pi over 6. And f prime of x is never undefined. Now we draw the number line of f prime of x and put critical numbers on it. To find the signs between the critical number, we plug in the numbers between two of them into the derivative. Now we estimate the graph of the function and we can see that f prime of x is changing sign 4 times.
F has relative maximum at x equals 5 pi over 6 and pi over 6 on interval of 0 to 2 pi because f prime is greater than 0 to f prime 5 pi over 6 equals 0 to f prime is less than 0. F prime is greater than 0 to f prime pi over 6 equals 0 to f prime is less than 0. F has relative minimum at x equal pi over 2 and 3 pi over 2 on interval of 0 to 2 pi because f prime is less than 0 to f prime to pi over 2 equals 0 to f prime is greater than 0. And f prime is less than 0 to f prime 3 pi over 2 equals 0 to f prime greater than 0.
Problem 3. Find the x-coordinate of the local extrema of the function f of x equals the cube root of 2x plus 3 squared. First, let's write down the equation and then take the first derivative using
The chain rule.
Then, let's find when f prime of x equals 0 and when f prime of x is undefined. So, here we know that f prime of x is never equal to 0. So now let's find when f prime of x is undefined. And now we know that f prime of x is undefined at x equals negative 3 halves. Now we're going to make a number line for f prime. We're going to plug in numbers before and after negative 3 halves to check when f prime is
Positive or negative?
to determine whether or not the point x equals negative 3 halves is a minimum or maximum. So let's test for continuity now. First, we got to make sure that f of negative 3 halves exists, that the limit as x approaches negative 3 halves f of x exists, and that f of negative 3 halves equals the limit as x approaches negative 3 halves f of x. We can now say that f of negative 3 halves exists, so now let's check for the limit. The limit from the negative side equals 0, so that means in order for the limit of f of x to exist, the limit from the positive side must also equal 0. And as you can see here, the limit from the positive side also equals 0. Therefore, we can say that the limit from the negative side equals the limit from the positive side. Therefore, the limit as x approaches negative 3 halves f of x exists. And since 0 equals 0, we can also say that f of negative 3 halves equals the limit as x approaches negative 3 halves f of x. We can conclude now that f of x is continuous. Let's rewrite the number line for f prime, and then use that to aid us in drawing the graph for f of x. Here we can determine that we have a local minimum at x equals negative 3 halves. This is because f prime less than 0 to f prime of negative 3 halves equal
Undefined.
to f prime greater than 0. And f is continuous at x equals negative 3 halves. We can conclude that there is no local maximum.
Thank you for watching Algeomila's Prep Academy. Make sure to like and subscribe.